Hey everyone, this video lesson is going to be just a simple continuation of the previous one. So the first two examples are going to be the ones that we just saw on the last one. So kind of think of those as if we were in class, kind of like almost like an exit slip or end of the lesson problem, and then we'd use that as a warm up. So these will still deal with the empirical rule, or that 68, 95, 99.7 rule. Anytime you see normal distribution, that gives you permission to use those percentages. So for a problem like this one, if we have a mean of 150, that's the center number, and a standard deviation is 15. So I add 15 as I go step by step to the right, and I'd subtract 15 going step by step to the left. The question is, what percentage of the students who took the test scored above a 180%? So I could think of that as taking this range of 2.35 plus this little region over here is 0.15%. So I could add those two together. Totally valid. Another way, if you really wanted to do that, is you could do 100% minus this whole region here, which would be 50 plus 34 plus 13.5. Either way, totally valid. You'd get the same answer no matter how you choose to do it. And that answer is, hold on, let me resize things here. And that answer is going to be 2.5%. Then it said if 250 students took the final exam, how many? And remember the key phrase here is where it says how many, not what percent, how many scored above a 135. So this whole region right here, basically 50 plus another 34%. So if we do that, we would get, 84% of 250, 0.84 times 250, and go from there. And then lastly, again, we talked about this in the previous video, if 13.6% of students received B, well, I know B is above average, so it'd have to be somewhere in this range over here. And it says about 13.6. Well, hey, that's about 13.6. Takes place between 165 and 180. All right, next problem that we kind of ended with is anytime you're given a chart like this where it kind of looks like a normal distribution, but it has individual bars, you are not allowed to use the empirical rule. Remember, the empirical rule is 68, 95, 99.7. You can't use that. Instead, you're going to have to kind of ballpark what are these bar heights. And you can see we have that written here in blue ink. And then from there, you're going to be adding together specific columns based on the question. So 69 to 71 inches tall, that would be these three columns right here. We'd have to add those three together. In doing so, you'd get about 43%. Similar problem for part B, less than 70 inches. So I'm adding all of these here that are less than 70, 13 plus 11 plus 6 plus 5 plus 3, so on and so forth. All right, let's get to some stuff you haven't seen yet. All right, so we want to take a look at normal distributions now, and we're just going to have a little less context with these, because really we only care about the mean and the standard deviation. As soon as I have that, I have enough information to label my axis for the bell curve, because I know all of the percentages that would be in these little zones, they're going to be the same every single time. So I don't really need to worry about labeling those. It's not a bad habit to get into if you want to throw those little percentages in there. Certainly a good habit to get into, but it's going to be the same numbers every single time. All right, so I know my mean is 100. So the middle number should be 100. And then standard deviation is 15. So I'm counting up by 15. I should make mention that this notation here tells me that we're dealing only with a sample standard deviation, not an entire population. So here's what my axis should look like. Again, 100 in the middle, counting up by 15s, or going to the left, counting down by 15s. All right, so now we have some questions to answer. What is the percent of IQ scores between 85 and 100? So 85 and 100, that's this little region right here. Well, if I think back to my empirical rule, that should just be 34%. Lo and behold, it is. Between 100 and 130. So this region right here. I know this is 34, and this, if I'm not mistaken, was 13.5. Add those together, 47.5. And again, I'm just using these percentages right here. So what's in green? Those percentages, even though they're not drawn in there. Oopsies. Oh man, I am just goofing everything up. Hold on. Hold on. All right. Nope. All right, so part D, the percent of IQ scores above 115. Now, there's two ways to do this. One way is you could say that's 13 and a half, that's 2.35, that's 0.15. Add those three together, totally valid. Or you could use something what's called the converse. Okay, so what I could say is maybe everything that it's not. So I could say, well, it's not this stuff in green. And this represents, let's see, that's 50, the left half, plus 34, so that's 84%. So then I could figure out what this area would have to be, because all total they have to add up to be 100. So that would have to be 16%. Lastly, percent of IQ scores below 70. So this little region right here. Well, I know that that's 2.35, that's 0.15. Simply add those together. Or I could do kind of what I just talked about. I know that this would be 50 plus 34 plus 13.5. And I can total that up and figure out what's left over to make 100. Either way is totally valid. I do not care which method you choose to use. You'd get the same answer here of 2.5%. All right, next problem. Very, very similar. We have our mean 64.5, so that's our middle number. Our standard deviation is 2.5, so that's the increments that we're counting up by moving to the right or counting down by going to the left. So what I'm going to do is I'm going to actually show you all of the questions, and I want you to pause the video here. Pause it for like 3 to 5 seconds, whatever. Actually, no longer than that. Pause it for as long as it takes to get these answers down. And then what I'm going to do is I'm actually going to go through and unveil all of these here. And you can see what the correct answers are. So here are the correct answers. Take some time, self-check, see how you did. Hopefully you aced it. If not, we'll do a quick, super quick little run through, and then we'll go from there. All right, part B says percentage of women between 62 and 67. Well, that's just one standard deviation in each direction, so that's 68%. Between 59 and a half, 69 and a half. Ooh, that's not a good highlighting job, my bad. Well, that's within 2 standard deviations, right? So that's 95%, so 59 and a half, 69 and a half. Shorter than 62, so that's this region over here. We have 13.5, 2.35, 0.15, add those up. Shorter than 59.5, well, we have 2.35 here, and then 0.15 here, add those together. Taller than 67, well, 13.5, 2.35, 0.15, add those all together. Taller than 72, so that's 6 feet tall. That's this little tail at the very end, that's 0.15%. And part H is saying between what heights to the middle, 99.7 fall. Well, 99.7%, that's 3 standard deviations from the mean. So if I go out 3, 1, 2, 3, that's here. If I go backwards, 1, 2, 3, that's here. So between 57 and 72 inches would be my final result. Whew. All right, so hopefully that all kind of made sense. Remember, as you guys are going through this, the empirical rule, or anytime you see normal distribution, just means you get permission to use those percentages and to label your bell curve accordingly with the mean in the middle. You know the drill. If you have any questions, please let me know, and I look forward to hearing from you soon. Good luck, have fun, be safe, Roll Tide.